All right. So I had a student miss class the other day for a very good reason. So I wanted to record a couple tutorials to help them with what we covered, especially at the beginning of the semester. We cover a lot of material. And I also figure it would be nice to have this as a reference for the students that were in class, because it was a lot of stuff. So you can refer back to this and clarify any things you might be fuzzy on. Okay, so I've just got the default open processing P5 sketch. I'm just going to press play and just, so we can see what the interaction is, right? I can move my mouse over the screen. And, if I wanted to, I could start, making this tight little drawing. Maybe I really like that shading. I want to create this little cluster, which is pretty cool, right? So I like this. I could just sit and draw for a while, do some things with it. The problem is I've got all this other stuff on the screen, right? This is annoying. I shouldn't have to draw like right at the very beginning. I want to draw where I want to draw on the screen. And right now my code, because it's just simple, right? Gives me a canvas and a background. It says, let's draw an ellipse, and let's draw it wherever your mouse and your Y are, mouse X, mouse Y are on the screen. So this is okay, right? But I need a little more control. And so in this tutorial, what we want to look at is, we're going to do an example that's a little different than this, but we're going to introduce a variable type called a Boolean, basically a true-false statement. And that's going to allow us to, in the example, make a circle get bigger or smaller based on this true-false thing toggling on and off. But later on in a separate tutorial, we'll see how we can use that so that if we press a key or release a key on the keyboard, we could make our drawing turn on and off, right? Wouldn't it be nice to be able to press a key and say, okay, now let's draw right here. And then when I'm done making the drawing that I want to make in a certain area, I can hit a key again and it would stop drawing. So I can move my cursor to a new location and I could draw a new little cluster of circle cells, whatever it is that they're doing. So let's do that. So I'm going to stop this. I'm going to go over. And in this case, instead of using ellipse, I like to use the circle. And I'm going to put the circle at the center of the screen. So I've got a width divided by 2, height divided by 2. We used that in class. And let's just make this 250. And press play. And I now have a canvas and I have a circle that does absolutely nothing. Very, very exciting, right? So unless this is my goal, to have a circle at the very center of the screen and never change the tutorial's over, right? Like, ta-da! But we do want this circle to change. So what we need to do is use a variable, right? Anytime you want change to happen, you need to use a variable. So let's create a new variable called D, and let's make it equal to 250. Oops, get rid of that little plus sign, a little period. So let D equal 250, and let's put that variable right there. And I'll press play, and voila, I have the exact same thing, right? But the nice thing now is because this variable is in there, I can now do a little bit of math, and I can change. So what if we just make the circle get 1 pixel bigger in its diameter every single frame? So to do that, we can do D equals D plus 1. And if you're familiar with, a little more familiar with coding, there's a little shorthand that I could use for this, but I think it's important to kind of do it the long way so that we can see the math right in front of us. And this math says whatever the D is, and of course at the very beginning we said D is 250, and we're going to draw the circle with the diameter of 250. And then this variable of the D that equals 250 is now going to be equal to whatever D is, which again is 250, plus 1, which means D is now equal to 251. And then we're going to go back, we're going to end and go back to the draw and draw a new circle. And this time it would have a diameter of 251. And then we'll do that little equation, right? 252, 253, 254. So let's go ahead and press play. All right, so I have created the ellipse, the ever-growing ellipse. And if that was my goal, right, I can just let it grow for as large as it wants to grow. But that's not our goal here, right? We want it to grow, but at some point we want it to stop growing. So to do that, we need to use a little piece of logic, right? We need to, in fact, let's write this in English. I'm going to use comment here. So keep making the diameter bigger as long as it doesn't get too big, right? So what is too big, right? We already have this bit of logic that says keep making the diameter bigger, so that's fine. That's what this is, as long as it doesn't get too big, okay? In fact, instead of saying as long as, let's say if it doesn't get too big. So if, what would be too big? Well, what if D got to the point that it was, what if we didn't want it to get bigger than 400, right? So we want to keep adding to it, right? We want it to get bigger and bigger as long as it is, or if it is less than, let's say 400, right? So if needs these little parentheses. This is the way of saying, okay, what's the if thing? Like, what's the thing I'm going to compare? And I'm going to look and see if D is less than 400. And if it is less than 400, I need to contain it in this little curly brackets, an open and close one, that just says, this is the stuff that I want you to do if this happens to be true. Right? If this evaluates in the positive, do this. But we put these brackets here because we don't want it to affect other parts of our code that we might do later on, right? So let's go ahead and see. So if D is less than 400, keep adding. Let's see what happens. And there you go. It stopped, right? It got to 400. At least it looks like it went to 400. Let's test that. So another little piece we use, so this is something you'll use all the time, is print. And print is a way of asking the computer, will you please print out what it is you think D is, or what your understanding of what the value of D is, so that it's clear to me, because it looks like it's 400, but can we see that it's 400? And there's a bunch of numbers down there that just kept scrolling. It's probably tiny on the screen capture. And of course, eventually it got to 400 and it doesn't change. It's just continually saying 400, 600, 700, 800 times, right? For every single frame that goes by. Okay, so this is pretty good, not bad. So the problem is I wanted to get to 400, but then what I've said right here is I want it to grow as long as it's smaller than 400. But once it gets to 400, what I really want it to do is to get small again. And then once it gets to a certain size and when it's small, I want it to get bigger again. So I can't do that with this mathematical approach, right? I can't say, well, once it gets to 400, then start subtracting, because then it will be less than 400, which would make this true, which would start adding, right? So it wouldn't do that. So we're going to deal with that in another piece of another variable in a different set of logic. But let's finish off this if statement. So knowing that I need to come up with a different, well, in fact, let's do it this way. So this is not going to work, right? Because at some point, I just need to know whether or not I want the thing to grow or not grow. That's what this equation needs. So let's go up to the top and let's add this new type of variable. So let grow equal true. And let's put that in there. So let's just say if grow is equal to true, and I just did a couple new things here. I'm going to explain that, right? Let's go ahead and make this bigger. So let's just press play. And you can see that it's getting bigger because grow is true. I said grow is true up here. I look down here and I'm asking the question, does grow currently equal true? It seems to be, because it just continues to grow, right? It just keeps getting bigger and bigger. So I'll let that, well, let's just reset it again for a second. So grow is we're just declaring any variable, and in JavaScript we don't have to tell it what type of variable we're doing. But in this case, by saying it's true, JavaScript's like, oh, this is not a number, this is like a Boolean. That's cool. This is a true-false statement. So, and then the other thing we've done here, if we have 3 equal signs, which in JavaScript, other coding language would be 2 equal signs, but this is not saying D equals a number, right? D equals 250. When I use 1 equal, it's like me saying, your name is Bob, right? My name is Dane. The if statement down here with multiple equal sign, this is my name Dane? Right? Is that true? Is this really Dane? Oh, if you are Dane, let's go ahead and keep talking in the tutorial and being ridiculous doing this tutorial. So that's what's important to understand about some of these symbols, right? So as long as this is true, let's go ahead and add. But at some point, if growing is not true, let's actually make it get smaller. So the way we do this with the if statement, we say if or else, let's say D equals D minus 1, right? Because we want it to get bigger as long as grow is true. But if grow is not true, then let's go ahead and make it smaller, right? Now, if I play this, I'm not going to get anything different because I don't have anything that says, hey, let's go ahead and make grow not true. Okay. But once we do that, we do have the code that says, oh, if you're not true, let's go ahead and make you smaller. So let's deal with that little bit of how do we turn grow off? Well, we kind of did this a little bit ago. We did a little if statement that said, well, how big is D, right? So keep making the diameter bigger if it doesn't get too big, right? Let's just cut that little comment. Let's put it here as well. I mean, I could leave it there. So again, what we want to say, well, if D is, let's say if it gets to the point that it's equal, oops, not 4, just 3. If it's equal to 400, let's go ahead and say, well, all right, let's turn grow and make it equal false, right? So once this becomes false, then this will go ahead and this will no longer evaluate as being accurate, but this will go ahead and then, well, it will skip this bit of code and then we'll go on and do this because this is not true once I turn it to be false. So it's still growing, right? Because it's true. And then it started to get smaller because this is taking over and it's doing a weird thing on the screen, right? So what is that? So before I move on to explain this part here, I want you to keep in mind, in fact, I should play this one more time. So let's look at this. So it gets bigger and the numbers down here get bigger. And now they're getting smaller, 200, 100s, single, right? And it got to the point that, but it seems to be getting bigger again. What happened? It actually is not getting bigger. It's getting negatively sized, right? So this is actually negative 700, negative 800, negative 900. So when we define shapes in processing, it can have a negative size, right? I can make a circle negative 800 diameter. The beauty of math, right? The other reason why this is evaluating kind of weird and we're getting that streak, right, is because the background was drawn once, but then it's never drawn again. So the circle is just being drawn over and over and over again. As it starts to get smaller, it's leaving the black line as it gets smaller from each one of the larger ones here. So all we need to do is just, let's take that background and put it in draw. So every time it does a frame, every single frame, it will erase that. Okay, so it's still going to do this inverted thing. So that's not quite right because we have a logic that says, hey, if you get to be equal to 400, go ahead and make this false. But we don't have a statement in here that says, hey, once you get small enough again, then go ahead and add it. So turn grow back on, right? So grow until you get a certain size and then don't grow, which will make it, in, of course, because of the math here, will get smaller. But once it gets small enough, let's say, no, let's go back the other way. Go ahead and grow again. So let's take this bit of code and copy it. And this is not the cleanest way to do this, I understand, but for the more experienced. But what if the original size was 250, right? So if we say, well, if D gets to the point that it's equal to 250, right? Because it was getting smaller, right? Once this becomes false, it gets smaller, smaller, smaller. And once it gets to 250, we actually want it to become true again. So let's see what happens here. All right, so this is working just fine. It is a little, and part of the reason it's working just because I'm using this nice round math. A better way to do this, I guess, because I know it's going to move itself on and off, is to use a slightly different piece of code, which I'm going to go ahead and do. But I just wanted you to see that we can set these up if the lower number condition is met, or the higher number or the lower number. We can say, hey, grow is false and or grow is true, and we'll just turn this back on and off. Another way that we could do this is just tell, let's do this. And this is what I did in class. I'm going to go ahead and show this. Maybe I should have just shown it the other way. It's a little simpler, but this is just clean. Let's copy this code. Copy. Right. So these two, I think those are called pipes, I believe. These are right above the return key next to the, let me just show this. Right. Next to the backslash. Is that forward slash? I can never remember which one the slashes are, right? But these two pipes here on your keyboard are the or statement, right? So if this or this, let me get rid of this. Well, this one, we want it to turn false. This one, we want it to turn true. So this is I find this is so useful once you get used to this idea. So whatever grow is, we want it to equal the opposite of what it is, because we have a true, or we have a thing that will make it false, and we have a thing that will make it true. So let's just say, if either one of these happen to be true, go ahead and make grow equal the opposite of what it currently is. And that's what this little, with the exclamation mark says. Say, whatever this is not, right? Let's go ahead and play this. So it does the same thing. It's definitely less code. The other thing too, in some instances when you're using these true false statements, it depends on what you're trying to do, but I just think it's an easier way to keep track of what's happening if you're going to just make it go on and off and on and off and on and off. So either one of these approaches would work, right? So we've created the kind of logic. The one reason I set this up is actually for later on, and when we write the code for the drawing machine, if I press and release a key and I tell it, like let's say we have a variable called paint, right? So when we were painting on a screen, so if I set that to be false and I press the key, it will make it true. And if I press it again, it will make it false. And that would not be possible with the version that I had before, true false. In that case, I just want it to say every time I release the key, toggle it between what it is and what it isn't, right? Just go from true, false, true, false, true, false, back and forth. So that's why this little thing, don't be afraid of it. It's really important, and we have to use it in the next little example. Okay, let's recap while this is pulsing back and forth. We used a couple of variables because we needed change, and therefore we need variables. We have a new type, right? We used this thing called grow. And again, this could be named anything. We could call it tree or dog or cat. It doesn't matter. But obviously grow makes a lot of sense with what we're trying to do. And we made it equal to true, made it true to begin, and we made it false later on. We did a little bit of math, and we used this new evaluation, right? We used the equal sign not to assign something, but to ask a question to see if something is true, if they evaluate as a yes or no. Okay. That was a long tutorial. How long did I go? 20 minutes. Just a little over my self-imposed limit. All right, so this is part one. I'll do a second one that looks at how to create a little drawing machine, and we take the same idea of using a Boolean, but to use it with a key press so that we can turn our painting machine on and off, our paintbrush. All right, hope this helps.